Okay, so let's look at differentiating each one of these expressions. Starting with number 1, dy by dx, remember, is a result of differentiating, represents our gradient of this graph. The fact that we've got negative indices doesn't change anything. Minus 2 times 3 gives me minus 6. X, take care decreasing the power by 1 because minus 2 decreases to minus 3. Then minus 1 times 2 becomes minus 2. So just be careful with the sign there. Like I did, I nearly rushed ahead and put in a plus. So 2x decrease minus 1 by 1, it goes to minus 2. So the process is the same, but just like when we work with numbers, negative numbers anywhere else, we just need to take a little bit more care. Question 2. So working with fractions again, exactly the same idea, you've just got to take more care. This means that you need to be able to multiply with fractions. So multiplying 1 by 3 over 2, we just get 3 over 2. X to the power of. When I want to decrease this power by 1, I want to take off 2 halves. So actually what happens is when I do this, take off 2 halves, all we do, a little trick, is we take the denominator away from the numerator. So I get 1 over 2. This works for every fraction because in one whole there are 2 halves, in one whole there are 5 fifths. So whenever we're subtracting 1 from a fraction, we're essentially subtracting a denominator from the numerator. So multiplying 2 by 2 fifths, what we do is multiply the whole number by the numerator, so I get 4 fifths. X. Decrease the power by 1, so it remains over fifths, but I take away 5 from 2, and actually this time we get minus 3 fifths. Okay, now what these first two show you is that you're going to have to be able to deal with multiplying by negative numbers and decreasing negative numbers. Question 2 shows you that you need to be able to multiply by fractions and subtract 1 from fractions. If you know that fractions is a topic that you struggle with, or negative numbers, you know you must revisit them. Okay, so question 3 onwards. When we have negative or when we have reciprocal or roots in our expressions, you must rewrite them as negative and fractional indices. So before differentiating, before we find dy by dx, write roots and reciprocals as negative and fractional indices. And the only reason I'm writing this here, so all negative or fractional indices, is as I really want to emphasize this step. This is the whole point of the warm-up in this lesson. So you must do this step, otherwise you cannot differentiate. So if we start off with number 3. First of all, I write y equals because I'm not actually differentiating at this stage. I'm going to write square root of x cubed as x to the power of. The power is the numerator, the root, which is a square root, is the denominator, plus x to the power of. 2 is the numerator, so the power, and then the root is the denominator, 2 fifths. At this stage, I can differentiate. So dy by dx, multiply by 3 over 2, we get 3 over 2. X, decrease the power of 3 over 2 by 1, so I'm going to subtract the 2 from the 3, gives me a 1 on the top, over 2. Plus, now let's multiply by 2 fifths, so we just get 2 fifths. X, decrease the power by 1, so the denominator again stays the same, but we're going to subtract the denominator 5 from the numerator, which gives us minus 3 over 5. Okay, number 4. We have an expression involving negative indices. So 2 times This is the denominator here is x to the power of minus 3, so we get 2x to the minus 3. Next we get minus 1 over 3, so 1/3. Remember that the 3, we don't change that at all. We write this just as a third times x squared would be x to the power of minus 2. Once we've rewritten it, then we can differentiate. So, multiplying the coefficient 2 by the index minus 3, I get minus 6x, decrease the power by 1, minus 3 goes to minus 4. Next, I haven't done the sign yet, but I'm going to do minus 2 times minus 1/3, so whole number multiplies the numerator of your fraction. So this is going to become positive now, because it's minus times a minus, and we get 2/3 x, and then I want to decrease the power of minus 2 by 1, and it becomes minus 3. So actually you'll find that really the only real challenge with this isn't necessarily the differentiation, it's can you work with negative indices and fraction indices. Additionally, for these last few questions, you need to be able to accurately write roots and reciprocals using negative and fractional indices. So again, this last one really starting to get into as tricky as they get now. First of all, the coefficient 2 is untouched, we'll just leave that. So this root we're going to write as x to the power of, the root is 3, so that's my denominator, the power is 4, so that's my numerator. Plus, this time we've got a root that is a negative index, so what I'm going to do, we can do this in one step. I just put the negative first of all and then focus on what's happening underneath this fraction. So the numerator is 3 because it's x to the power of 3. The denominator will be 2 because I can tell this is a square root since the number isn't written. So I get minus 3 over 2. Finally, I can differentiate. If I differentiate 4/3 times 2, remember we only multiply the numerator, so I get 8/3 x. I want to decrease the power by 1, so the denominator stays the same, that's still a 3, but I'm going to subtract the 3 from the numerator, which is 4, so I get left with a 1 on top. Taking care for a second, I'm now going to multiply when I differentiate my second term. Minus 3 over 2 times x will give me minus 3 over 2 x. So what I'm going to do is I'm now going to put still a negative index. When I decrease this power by 1, the numerator is still going to be 2, but now I'm going to subtract 2 from minus 3, which gives me minus 5 over 2. Okay, these last questions are as tricky as they get. This is what we'll be looking to deal with in the C1 exam at the end of the year.